In this video, we will learn about the general formula for first order linear difference equation. So given a first order linear difference equation, that is yt is equal to b yt minus 1 plus a. This is our first order linear difference equation. It is our first order because greatest time lag is 1. Okay, we have t minus 1 here, and it is linear in the sense that all the variables are raised to the first power and there are no cross products. Okay, so this denotes our first order linear difference equation. Now here a and b are the constants. Then the general formula is given us, and let me write it here, where a and b are constants. Then general formula for definite solution, let me write it here. Then general formula for definite solution is given like this. That is, given this first order linear difference equation, it is solution is being given by, that is, yt is equal to y naught minus a upon 1 minus b times b raised power t plus a upon 1 minus b. Okay, here when b is not equal to 1. Okay, if b is equal to 1, then our general formula looks like this. That is, yt will be equal to y naught plus at. Okay, when b is equal to 1. Okay, now if no initial condition is being given, we add an arbitrary constant a. In the sense, that means we write this equation when no initial condition is given, we write this as y t is equal to, in place of this we write a arbitrary constant, we have b raised power t, and in place of a upon 1 minus c, let us denote it by c. Let me write it here, plus c. Okay, this is called the general solution, and here this arbitrary constant denotes, so our arbitrary constant is y naught minus a upon 1 minus b, and this c denotes a upon 1 minus b. Okay, so this is called the general solution of the given first order linear difference equation. Let's give an example, it will make more sense. Okay, remember this is the third video on this difference equation. You can check out for the basic concepts in video first and second. Okay, so let us say we are being given a difference equation. Let me write it here. Let us say we are being given a difference equation, that is yt is equal to minus 7 yt minus 1 plus 16, and we are also being given the initial condition is, let's write the initial condition here. Let us say initial condition is that y naught is equal to 5. Okay, this is our initial condition to find the solution of this difference equation. Let us first see what we are being given here. Okay, so here our b is equal to minus 7. Let me write it here. B is equal to minus 7. That means b is not equal to 1, so we use this formula. Okay, let me write it here. B is not equal to 1 here, so this denotes our b. What is a? A is 16. Okay, let us write, in place of a we have 16. Then our solution will look like this. Let's use this formula, that is yt is equal to y naught minus a upon 1 minus b times b raised power t plus a upon 1 minus b. Okay, so our yt will be equal to yt will be equal to, so y naught initial condition is being given us as 5. In place of y naught we write 5 plus a is being given us as 16 upon 1 minus we have another minus here, minus into minus is plus, we get 1 plus 7. So b is our minus 7, let's write here minus 7 raised power t plus a, again it is 16 divided by 1, minus into minus will become plus, b is 7. Okay, so which reduces to yt will be equal to, obviously here it is negative sign, so solving this out we will get, and let us see here what we get. We have 5 minus 16 divided by 8 minus 7 raised power t plus 16 divided by 8. So our yt is equal to, so 8 5s are 40. Okay, 40 minus 16 comes out to be 24. So 24 upon 8 is equal to 3. So we have 3 minus 7 raised power t plus 8 1s are 8 2s are 16. Okay, this is the solution. This is the solution of the given difference equation. Okay, now to check this solution, what we do to check the to verify this, what we do, and let me write it here for the lack of the space. So let us say this is equation first, and let us say this is equation second. To check the solution, what will we do here? We put, okay, put t is equal to 0 and t is equal to 1 in this equation second. Okay, one by one, that is when t is equal to 0, when t is equal to 0 in this equation. So this equation reduces to y in place of t we have 0, y naught is equal to minus, sorry, we have 3 first, then we have minus 7 raised power 0 plus 2. It will come out to be, we should, anything raised power 0 is 1, so anything except 0 raised power 0 is equal to 1. So this is 3 into 1 is 1, so we got here 5. Okay, that means when t is equal to 0, y naught is equal to 5. When t is equal to 1 in this equation, so we will get in place of t we have 1, y1 is equal to 3 into minus 7 raised power 1 plus 2. So this is 7 3s are 21, minus 21 plus 2 comes out to be minus 19. Okay, after that what will we do? Let me write it here. And what we got here, we got y1 is equal to, let me write it here, we got y naught is equal to 5 and y1 is equal to minus 19. Now after that what we do, we simply plug. Okay, let me write it here, we substitute y1 is equal to minus 19 for yt. So we put y1 is equal to minus 19 for yt in equation first, and y naught, which what we got here is 5 for y t minus 1 here. T minus 1 we put it into in equation first. So in the first equation, in place of yt we have y1 which is equal to minus 19. So in place of yt I can write y1 which is minus 19. So we have minus 19 is equal to, then we have minus 7 here, minus 7 y t minus 1. So in place of y t minus 1, we have y naught is equal to 5. So I can write it in this fashion. So we have 5 in place of y naught, and y naught is equal to y t minus 1 plus 16, and here you can see we have minus 19 is equal to 7 5s are 35, minus 35 plus 16 comes out to be minus 19. That means initial condition is being satisfied. Okay, so this process was only to verify for the solution. Okay, so the solution for this first order linear difference equation came out to be this very equation. Okay, and to verify the results or to check the answer, we substitute t is equal to 0 and t is equal to 1 in this equation. When we put t is equal to 0, we got y naught is equal to 5 in this equation, and when t is equal to 1, y naught came out to be minus 19 in this equation. Okay, after that we substitute y1 is equal to minus 19, that is y1 is equal to minus 19 for yt. Okay, we put y1 is equal to minus 19 for yt in this equation, and y naught is equal to 5 for yt minus 1 in the first equation. And then when we solve it, our LHS came exactly equal to RHS. Okay, so this is how do we solve the first order linear difference equation and the general formula for the linear or linear first order linear difference equation. Okay, if b is not equal to 0, then this formula we apply. If b is equal to 1, sorry, my mistake, when b is not equal to 1, this formula we apply. When b is equal to 1, we apply this formula. So this b plays a crucial role in determining the solution of a first order linear difference equation. Thank you.